Hello, Internet. Hello, friends. It's May the 30th? April the 30th. Thank you. I work in a lab all day. I don't... Oh, the sun. What is that ball of fire in the sky? It's April 30th, 2019. Thank you for attending my TAD talk. My name is Dan Royer. I have lived in Vancouver now for just over a decade, and I've spent nearly all of that time making robots. So I'm going to give you a little history about myself and what I've been doing, what I'm doing right now, where I'm going, and if you're interested, how you can join me in this. It follows that if you are bored, you can't entertain yourself, therefore you must be boring. My real purpose in all of this is, well, at first was just to not bore myself. If I can just entertain myself, that's really all I needed. This is my first robot in 2009. It's a six-legged crab that walks. I didn't know I couldn't do it, so I succeeded. That was pretty convenient. Arduino wasn't quite a thing yet, so the board that's in there you will not recognize. This is back where I started when I was about 9 with the 8086. For you kids who don't know, that's like 20 megs of RAM. It's huge. In 2000, a friend of mine asked me to contribute to a book on writing video games. There were no late night infomercials about join our game programming school, and Unity wasn't a thing yet. We were all teaching each other on the internet. And I guess I knew something because he asked me to contribute. So that book got me a job in Israel building medical training simulators. We would sit around at lunch eating while watching videos of how to insert endoscopes into the male urethra, and then we'd debate how to simulate tissue that was, flaking off, or how do we make the kidney stone work right. And we had a basketball hoop set up in the bladder and throw kidney stones into it with the endoscope tool. And then there's an anatomically correct dummy on the table that would fight back if you push too hard to simulate like trying to poke through the wall of the lower intestine or something. Then I moved to Israel for 2 years, and I worked at a company called Ratback Games in Adelaide. They were one of the very first companies to make a hardware accelerated video game, like that took advantage of a video graphics card. And all they did is dirt track racing games. That's what they were known for. So if you really like turning left, this is the game for you. It was huge in the southern US. Then I came back here and I worked, the most significant job would be EA. I got in for 3 months there and worked on Need for Speed Underground. They gave me a choice of a hockey game, a race car game, and a skateboarding game. Yeah. I'm only going to say nice things about them. At the interview, they asked me what I wanted to do while I was working at EA, what my long-term goals were, and I said I want to finish work on my laser, and I did the finger quotes, and somehow they gave me the job. So that was unexpected. I have spent in these last 10 years a lot of time at the Vancouver Hackspace. The picture on the left here is from the first space that we had, which was behind the Save On Meats downtown. For those of you on the internet, the back alley is in the downtown east side, so you can expect to see dirty needles and rats, and there's a bar next door that people would come out and pee in the alley, and we would occasionally shame them with a spotlight. This pulley right here had a rope on it that had the key, so if someone rang the buzzer, we would lean out the window and do a kind of a French Knights routine, and if we liked them, then we'd lower the rope and they could get in the door. The picture on the right is like 2 physical VHSs later. We've moved a couple of times. I say we. This one was hot pink, and this was the main work table where everybody gathers around and works on whatever they're doing. There's a lot of cross-pollination happening, and this white square in the back is a giant wall of LEDs that I've worked on in the past. We'll get more into that a bit later. So yes, my first robot was Spidey. I had to cut the audio out of the original because there was copyrighted stuff, and this was the option they gave me. I took the parts from my computer design, I threw them in an empty video game, and I played with it until it stopped exploding, and then I copied that code into the Arduino, and what do you know, it actually worked. It can just barely hold its own batteries, and those servos are not smooth, which is most of that jerk. I was pretty proud of myself that I could do things like rotate the body without moving the feet. And I'm glad this still has some pep. For those of you who might be worried that this is a lot of programming or a lot of math, my math ends in high school with trigonometry. I think that's enough of him dancing around. Her dancing around? It dancing around. Yeah, which is going to be embarrassing later if you see some of the bigger creations that I've made. Well, embarrassing to me, I think. I'm getting better, I hope. So, this is a picture from VHS 1, my first attempt at a polar graph. So the two motors at the top turn, which pull the ropes, which move the bolt around. But if you change the bolt out for a pen, and you put something that can lift the pen off the paper, you can draw any picture you like. This machine that you see down here is the Makeline 5. We've been through a couple different versions, and whenever we find the time, we make new improvements to it. So it draws pictures like this in maybe 15 minutes, probably less. And there's one on the back wall. You can get a closer look a little bit later. We do them in CMYK in 4 colors, and you just load in a bitmap and say go, or a DXF file if you prefer. I would love to work with someone here in Vancouver at the Mural Festival and do one but huge, right? With pointillism from a spray can, maybe a solenoid that just hits the top so it doesn't dribble down the wall. I think that'd be great. There is a machine called Hektor, Hektor, that I think lives in California, and there's an artist there who does that already. So I've shied away from it. I don't want to horn in on his territory, but I feel like it would work. It would be fun. I built this machine with 2 motors because my real goal was already at this point to build a robot arm. So I learned to use 2 motors, and then from there I learned to use multiple motors. The machine in the back on the left has 3 motors. The one in the front has 6. So the one in the back is what's called a delta robot. When it moves, it's always parallel to whatever beneath it. And the one on the right can tip as well as slide. That's what you'd see under a flight simulator for a cockpit. So that's how airplane pilots train, because it really gives you the feel in the seat of your pants of the motion, which apparently pilots need. I don't question it. These parts were made out of aluminum because I didn't have a 3D printer at this point, and I think there's a total of about $600 in machining there. So yeah, metal machine. If you've never costed it out, learn to be a machinist or get someone who really loves you and has a machine. I got scooped at least once. This is, on the left, is a Delta robot I put in a cardboard box that was at the 2011 Maker Faire, the first Maker Faire we had in Vancouver. The one on the right is the first Kossel 3D printer. Now, I knew Johan from my couch surfing days. I was in couch surfing before they had 1 million people on their website, and things were still pretty hip. So I put this video up, and a year later he came to my booth at the Seattle Maker Faire. He called me up Sunday morning and said, "Hey, can I come out and show something at your table?" I'm like, nothing could be better than my drawing robot. I was wrong. But that's all right. I'm just glad it exists. Somebody did it. This was an upgrade to Spidey. It's an all-metal body. It looks neat. It works about the same. I'm actually talking with some people at Emily Carr right now. This is 4 motors around the top of a box. So instead of, it's like 2 Michelangelos put together. If you control all 4, you can make the thing in the middle, this point P, go anywhere you want. You may have seen this at football games when the camera comes right over the middle of the field. Again, it's basic trigonometry. You don't need anything more than like law of cosines or something. at the same time that I was doing that picture I was talking about, giving a presentation at the Hackspace about making an arm. Some other things. At any point, if you have any questions, please stop me, ask them, go on. I showed this unit. This is the more recent version of the original on the left, which is a piece of cardboard with, what is that, duct tape? And some of those parts aren't even held down. And it has no battery. It's got a run plugged into the wall. Great fun. Iterations. A lot of these designs, I'm skipping a lot of the middle stuff. You don't get to see them. The picture on the left, actually both of them, is from like a Michelangelo 2. I couldn't even lift a pen yet. So I had to draw everything as a single giant continuous line, which was really weird because it would do a little bit over here and wander down over here and come back over there, and like an hour later it would come back around and finish up in the corner where it began. Didn't make any sense to anyone but a machine. I finally started getting into some 3D printing. In 2013, the 3D printers were like 1 in 10 prints would work for me. That they were still not great. So this motor spins really fast, and you put a ball on the end of this. As long as the ball is pointing straight down, it just spins like a top. But we all know what happens when a top starts to slow down. It goes poof, off across the table. So if you control the angle with these two motors, you can control the direction that it spins off in, and you can use that as a very cheap RC car. And they are really fast. You make them light? Yeah. At about the same time, I was trying to make a drink mixing robot. So the bottles go on the black nozzles on the top. The two belts at the bottom pull the scissor lift left and right. But if they work opposite each other, it goes up and down, which raises the glass to hit the dispenser, and you get like half a shot from each, something like that. And the reason it was made this way was so that there was no wiring or things that could get wet and then short circuit under the bottles. You can see a Raspberry Pi on there, an Arduino, the stepper motors, and because I didn't have an easier way to power everything, I just threw a USB hub in and zap strapped the whole thing together. This was a commission. It was a pan and tilt. It was all laser cuts for a GoPro. Somewhere on the VHS website, there's a panning time lapse of the thing at a party. I could not locate it, but I know it's out there. And you can see an inside shot. So this is multiple layers of wood glued together, and all of these parts were designed, I think at this time I was working in SolidWorks. I have since switched to Fusion 360, and if you're interested in learning Fusion 360, let me know. I'm always happy to run another class at the Hackspace and give people an introduction. We typically design a little ring, print it in 15 minutes. You go home with a new piece of jewelry that has your initials on it. The lovely Heike back here draws me up paper sketches of something new that she wants, and I make it happen. So we've got a nice little artistic collaboration going there. Check out her Instagram channel if you can. Heike Cap on Instagram? Yeah. This, we talked about, before this thing began, we talked about quadcopters. So this is my dog Bug. He's a rescue. I didn't make him. But behind him is the first iteration of a quadcopter that I built with John not Craver. His last name has escaped me, but it was a John. Not Craver, no.
Riemann.
Yeah, thank you. Yes. He knew all the technical details. I did the laser cutting and financed, made sure we could pay in advance to get everything before we collected all the cash. I can't fly this anymore, but it stands on the wall. It's not that it doesn't fly, it's that I don't have the license. So back then there was no license. I'd be out doing it and people were like, get that away from me at Science World, out on the lawn. That was nice. We didn't try buzzing anyone, but yeah. Some other things that we've made. You can see this was the fun one. The one I like the most is probably the dog house that was a geodesic dome. The top right is the vending machine I used to have at that space that had electronics and candy in it. Everything a growing hacker needs. We had some safety gear in there too, and fresh batteries, and gum, because who doesn't want? Yeah. Pictures of cats. My favorite cat right here, Miles Davis. And different styles were starting to be added to the machine. I should mention that the code that converts pictures into lines is open source. So if you get inspired to, oh, I want to do a new algorithm, please throw it in here. We also recently made sure that we support every design that's on a website called turtletoy.net. Let me see if I can, give me a URL here. No? You're not going to let me because we're in a presentation? Okay. So now we get to some of my early ARM work. This was a 3-axis ARM. The pen is always vertical to the table as long as the design is stable. And on the far right is that, remember I mentioned an empty video game? That's what it looked like at the time. These lines may not be much, but they're dimensionally the right length to check that the math is correct and it's going where you want. I had it writing out tweets at the Seattle Maker Faire, and later I was doing, this is the next version. I had a kid would come over and hold the paper down for me, because that way I didn't have to tape it in place, and then would write out, hello, that kid's name, and it seems to hold them down long enough that I can talk to the parents about what I'm working on. There's a big distraction factor at those kind of events. 2017 up there, so that's October. I never even built that unit. There's a lot of designs that never saw the light of day. The one on the right, I built 2 of them at different points. And you can see up above it, and if I walk over here, this ARM was actually made for me by UBC students. So at various points, I've hired lots of people to help me. I continue to do so, and my next thing is actually getting a project manager in who will probably then hire more people, because I just can't go fast enough. It's like there's money on the table and we just have to pick it up. My arms aren't long enough, or fast enough maybe. Yeah, so some people I meet along the way, I don't know if you recognize any of these faces. Wendell in the bottom right there is from Evil Mad Scientist Labs in California. The guy in the top right does biohacking. Angel Gouffria is, she's a well-known artist. She's an actress in the southern U.S. And Sarah, this is Super Awesome Sylvia. You may have heard of her YouTube channel. And Bunny Huang wrote the guide for Shenzhen makers. So if you don't know Chinese but you want to go to Shenzhen, he's got a pictogram guide. You just point at the words and the other person who only speaks Chinese will be able to figure it out with you. That's very convenient. I spoke of a giant wall of LEDs. So I started with one of these little things you can get for about $2 at Lee's Electronics here in Vancouver, and used a couple of chips called shift registers. You feed everything in through just one pin. As long as you remember what you're doing, you can make it say any message you like. So it was animated text scrolling messages. And then from there it was a short jump to doing full color. We did these 8x8 panels. So this is 4 panels by 3 panels. I taught, what would it be? 12 people, more, but 12 people left their panels behind after the class. They donated them to the Vancouver Hackspace, and we wired them together to make a Jumbotron. Some other people had done LED walls in the past, but they had put the entire animation, like a GIF, was all they could fit in the brain of whatever chip they were using. And I figured out how to get the chip to listen to whatever message I was sending it from the outside, the same way your TV would. So then I could stream a video from my laptop to the wall, and we could run infinite video all the time. At the space, it just runs a couple of demos in a loop, and it's open for hacking. It's running on a Raspberry Pi. You can log into it and create new stuff on it and experiment for yourself. Make some digital art. The piece on the right, there's a local band called 5 Alarm Funk, and he wanted a hat that would display messages and do funky lights, and we definitely made that happen. I'd love to make a coat of many colors, or I have a long-standing project for a Burning Man art car. It's shaped like a ball, and the lights face outward. so at night it doesn't blind the driver. And at night, all you see are the lights from a distance. So by changing the pattern of lights, we can make it look like the ball is rolling at the same speed the car is moving. So it could be a giant 8-ball, or what, magic 8-ball, yeah, or an actual physical eyeball that's rolling across the desert. I think that'd be kind of neat. And during the day, I wanted to put a 360 camera on the top and do a slow tour of the entire Burning Man. Then at the end, we'd take all of that data, strip out the faces and the boobs and the license plates, which they would do anyways, to anonymize it, and then put that on Google Maps. Because Black Rock City is the only city in America that isn't on Google Maps yet. And I feel like we could put a pin in that. We could close that loop. I'm sure lots of people are going to have fun talking about privacy at Burning Man with that. So, controversy sells art. So this was my first line follower I built kind of on a dare. These are photoresistors that are basically rubbing on the floor, and the gym floor had those painted lines, so we could follow those pretty well. The one on the right is a maze-solving robot. I spent a ridiculous amount of money making a modular maze for a contest at one of the maker fairs, and nobody showed up for it because my marketing could be better. I don't regret it. It was a lesson. Where I'm at. These are some of the lovely people in my life right now who are helping me out. We've got some of my interns. One of the Alpha Secondary High School sends me all of their best. I only take the best. And they're highly motivated guys and girls. I couldn't find a picture of the last lady who came through. But I don't care what's in your pants. I care, can you do the job? My buddy up there, my head of IT on the far right, head of engineering in the bottom right. This was the Hand of Man. This was a giant robot arm that I last saw them in St. Petersburg. They let me drive it, and we dropped a piano on somebody. They tour all over the world. Not on somebody, excuse me. That's just in my dreams. So yeah, I mentioned the Michelangelo robot. Once I built it, I have to say right off that I did not build the first Polargraph at Vancouver Hackspace. Somebody there had built one as well, and it was the same problem. The entire program was in the brain of the robot, and I figured out how to send it countless amounts of data so you didn't have to reprogram it, which opens it up for any artist. Now the machine on the right, that's basically what it looks like when it ships. That was taken at Science World. And the map in the bottom left, when you first get a Michelangelo and you plug it in, it phones home once. It gets a unique ID number, and I get the IP address that I can map to somewhere in the world. So it's like your neighborhood, not your actual house. And then I can count how many there are in the world, when they've been turning on, and I've been like, we don't have much penetration in Northern Africa. We got to work on that somehow. I think my favorite is, there was one, I don't know why it didn't show up, but there was one out here in the middle of the ocean. I couldn't believe there was anyone on these islands, because I'm ignorant, I guess. But it was great to see a pin show up. There was somebody who read the open source code, figured out that it was doing this phone home thing, and the way I discovered it is that I looked at the graph one day, and suddenly new machines had gone just crazy high. And I looked into it and found that he was pinging that IP address, the specific whatever, once a minute, and he'd been doing it for about 3 days. But I knew his IP address, so I looked up his IP address, found his registrar or his internet service provider, and then sent them a friendly email, and it was gone. So, yes. I wish him all the best. Very clever, whoever that was. So earlier I showed a Stewart platform, all made out of metal. This is a more recent iteration. The red parts down here are all 3D printed, and it works pretty much the same as before. On the right, you see 4 platforms, but the 2 that Jin is holding are the inputs, and the 2 that are in front of him are the outputs. So you can remote control something. This would be used, for example, in telerobotic surgery or animatronics. I'm sure Disney has done a couple things like this. And there's no limit to the distance between them. You put the internet in the middle and away you go. So again, on the left here, for comparison's sake, this is the first robot arm that I made. This was 2018, the 61. And on the far right is one of our recent pictures of 62. That is a 5-pound weight in its hand, so it's 2 kilos. The goal is, right now our target is 84 centimeters of reach, 2 kilogram payload. That's like the wrist ends just flat. So whatever tool you put on there plus whatever you're carrying, and a 0.5 millimeter repeatable accuracy. That should be enough to put a 2 millimeter screw in a 2 millimeter hole, which is the smallest part we have on the arm. Because when this works right, we're going to eat our own dog food. We're going to have this machine building copies of its sisters. And I hope that's the last time I build a robot by hand. Because after that, I'm just going to make the arms. I'm going to focus down like that and hopefully get them to everyone. So where I'm going, I want to use arms to make arms, much like this animation is demonstrating. And as it says, so if you have economic power, you have political power. If robots take all the jobs, robot owners have all the economic power and therefore all the political power. So we have to have open source robot arms in order to ensure the future of democracy. I'm not saying all democracy hinges on it, but let's, you know, of the many problems that we face, this is one of them most people aren't thinking about. I'm a moderator on Reddit Robotics. I don't know how I got that job, and I put in a rule there that said no futurism. I feel like I couldn't post this on my own subreddit because they would report it for futurism. Yeah. So if these robots sell, drawing robots, robot arms, whatever it is, robots with happy faces on them to tell you that they love you, I don't care. I just need to make enough money so that I can go on to my big dream project, which is a bulldozer we put on the moon, and it has a Fresnel lens on top, basically a magnifying glass. You smooth out the dust, which is mostly iron, you melt it with the magnifying glass, repeat, 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 3D print buildings. The problem with moving to the moon and living there is you need a place to live while you build the place you need to live in. The cost is too high. 5 years ago, I was saying it would cost like $100 million per attempt. And we've just seen the Israelis try it for exactly that price. I think it's 3, maybe 5 tries to get it right, to successfully land and drive the bulldozer. The biggest problem will be nightfall. It gets very, very cold and the batteries crack. So I think that's the biggest problem. But if we can pull it off, then we can live there. And people say, well, why? Well, I don't know if you've noticed, but we have some problems down here. And was it Arthur C. Clarke who said the earth is too small a basket for us to keep all our eggs in it? And I'm just saying a plan B was a nice thing to have, right? So while everyone else works on reducing carbon footprint, this is my driving force. Yeah. So if you'd like to join me in any of these projects, I'm always looking for help. You can reach me through many channels. The link above is the one I put in my Instagram bio, which takes you to everywhere else. You can get to my GitHub from there. You can get to Patreon from there, all that other stuff. And I'm always happy to collaborate. Just yesterday I was teaching someone who had built a mask. They wear the mask and it's covered in LEDs. They 3D printed it. And they were trying to work out how to make video play on the mask. So yeah, a lot like the wall LEDs, filling in that missing piece of the information. I'm big on education. I'm big on moving forward and big on working together. I try not to let my ego get in the way of important lessons. And I'd love to learn from you and to share knowledge. So that's the majority of my talk. And I guess I open the floor to questions now. Thank you very much. Now I can get out from behind this stuffy podium because I don't have to touch anything there anymore. So, talk to me. Hi.
real simple, not technical question, but it occurred to me when you showed the slide with the drone and the dog in the foreground, and you sort of joked about having not made the dog. It reminded me of something I've felt numerous times. I wonder if you or anyone else would feel the same thing. Sometimes I'm working or I'm out and about not working, and I see an insect or some other small creature, but insects in particular, and I sort of once I began working with robotics a few years ago, right, and sort of grasp what level of complexity the robotics that we're currently at, how complex they are, and sort of the state-of-the-art stuff, I find myself very humbled by the complexity of something even so banal as an insect, and I just am mesmerized by it, the fact that this thing is so tiny. It's able to some extent repair itself, right? Fight infections. It's able to reproduce itself. It has enough intelligence to navigate its way around the world with lots of predators and hazards. And yet it's so tiny and so exquisitely sophisticated. I find it's very humbling thing. It's a good reminder to me sometimes, and I wonder if you've ever had a similar experience.
Very often. There's so many parallels between robotics and biology, and I mean, it's not fair that evolution has had 1 billion years to work these problems out, and I get maybe 40 to start learning about it. I won't even scratch the surface, right? There was a while back, I wanted to make a soft robot that was like a tentacle, and it had chambers in it filled with fluid. By changing the pressure in the chambers, you could make it bend wherever you wanted. My concern was that it might crack, and then you'd get fluid everywhere, and it wouldn't stop until the pump ran out of juice, and then the pump would run dry, and that would burn out, and oh boy. And then it occurred, I thought to myself, well, Crazy Glue is liquid until it touches air, so maybe we could find a way to do it in a vacuum chamber and fill the whole thing with Crazy Glue, and then if you cut it, it would coagulate. Oh my God, we're filled with glue. And that realization had never occurred to me. We're filled with Crazy Glue, yeah.
I'd like to know your thoughts on AI, and if you've had any consideration or how it may relate to your process.
Okay, I have thought about it a lot. I read the machine learning forums. I don't understand it at all. Maybe I'm just too old to grok it. Maybe the tutorials don't speak my language. I want to believe that if it were explained to me in the right way, I could set it up and run it. I've run a few of the demos, but I don't get how to set it up for my own purposes. For example, in the robot arms, I can very easily calculate if the elbow is this angle and the shoulder is this angle, there's where the fingertip is. But going the other way is really, really hard.
Yeah.
And trying to say, we'll go from here to here without doing this, like there's a point when you pass what's called the singularity, and in every version of the math that I've ever written, you get to the point where it straightens out like this, and then it wants to instantly flip the wrist around to do this. So I thought, well, if I could train a neural network and just let it play with itself all night in VR, it would figure out how to do it. And then I could say, I want you to go from here to here, and it would just do it. And it would keep the elbow out of the way, and it wouldn't do any nasty flipping. So I would love to apply that.
I think that'd be very cool.
I don't know if that's the best way, but I suspect that it would have, that I'm sure other people have already started work on that. I would like to make that part of my open source. I talked a lot about the Michelangelo and a program also called Michelangelo that just does this. I have another program called Robot Overlord, because I for one support our Robot Overlord. I don't know about anybody else. There are now a dozen robots. All of my earlier robots, the Crab, they've all been upgraded and put in there, and I would love to put AI in there and let them play with each other and figure it out. That would be very cool. Yes, I hope that answers your question.
It definitely does.
I'm not concerned about AI like destroying us. I have this fantasy that in the Terminator scenario, they cull our numbers down to a manageable, like good for the environment, and then they bend their guns and pick up brooms and go back, clean up the mess. Because I believe in something called, I came up with this term, I call it mutually assured survival. Robots on their own can survive anywhere in the universe, but maybe, just maybe, there's like a solar flare that wipes them out, and they need someone to push the reset button that's not subject to solar flares. And we need them for the exact same thing. So maybe we won't find alien life, maybe we'll just build it on our own, and then we'll all do better together, right? As the Americans are fond of saying, united we stand. Cool. Yes?
Hey, I've seen you do a lot of work with like Arduinos and Raspberry Pis and that kind of hobbyist,
Thank you.
open source kind of stuff. Do you find you have a need to like level up like PLCs, or like what's the next thing from there?
If there is a need, I don't recognize it yet.
Copy that.
Maybe it's there and I'm ignorant, so I don't see that I should be doing this. And someone will come along, oh, why don't you do that? It'll be twice as easy and 3 times cheaper.
Mhm.
Done. Let's make it happen. Yeah. The problem, what keeps me up at night is, what you don't know, you don't know.
Mhm.
Experience is the thing you get after you need it, and if there's a way to get it faster, I would mainline that stuff. Just put it right in the vein. Yeah. Rubber hose and all. I don't know. I hope that answers your question.
Yeah, it does.
Okay. Anyone else?
If you don't mind me asking another one.
Go ahead.
What kind of failure did you learn the most from?
I had 5 stitches in the top of this thumb. Almost lost the thumb. Took off a big chunk of the nail. That was in December of this year. They say every accident you can find at least 3 mistakes. I was in a hurry. I wasn't thinking about safety, and I'm sure there were other mistakes made at the time, and yeah, I'm sure you can think of a few yourself. Anyways, I was trying to cut a slot through a tube with a router. Inappropriate tool for its purpose. Yeah, so it was a hack on a hack with no safety in a hurry. And yeah, I'm glad I live near UBC Emerge. So I have all my motility and feeling. My first cycloid, the gearbox that I was mentioning before the video started. So for those of you who are online right now, I've been trying to make gearboxes for my robot arms, because gearboxes are super expensive, and the ones you buy are sloppy. They jiggle. Like, you can hold them one side and wiggle the other, and that's terrible for robotics. You need precision and stiffness. So the cycloids are great and they're cheap, but the first one that I made, I tried to reach too far. I spent $3 grand machining the parts and engineering it and prototyping, and declared it a total failure because I tried to do things they weren't meant to do. And I need to go back and update my Hackaday post about that. Yes. Yeah, also at the channels you can find the Hackaday page that lists a lot of stuff about the 60 arm. And yes.
How much do you need to deal with slop in software as well as hardware?
In software.
Yeah, I mean,
I write sloppy code. Who
compensating-
doesn't?
Sorry?
I write sloppy code. Who doesn't?
I think he means backlash.
Yeah, I mean, like mechanical inconsistencies.
Yeah. My very specific technical problems, I don't know how I can sum them up quickly. There are sensors that can detect the difference between where you want to be and where you are. We have great sensors like that. They're 16-bit, so we can detect something like 0.2 of a hundredth of a degree or something like that, and that's enough to get our precision twice what we need at the full extent of our robot arm. And there's a lot of challenges in there. Come and join us, have a chat, see the real thing. We can get really down to the nitty-gritty. That'd be cool. Yes?
Just a follow-up question to what you just mentioned, but I was actually had it in mind already, which is you mentioned during your talk and just now about having robot arms built out of robot arms. You're talking about the tolerance of your error and how it's sufficient wondering, so based on what you're saying, I suspect I can infer that you're talking about an open loop design, but do you think it might be worthwhile to consider a closed loop, especially considering that depth cameras are now becoming so ubiquitous that it might be useful to have some closed loop going on there, even if your open loop precision is already quite good?
So the first arm that I made out of wood, both the beige one and the purple one, the purple one I tried to make closed loop, but I had lots of sensor problems. The 6E arm is open loop, the red one, and the yellow one is closed loop. We have those 16-bit sensors I was mentioning. We'll be able to push it to teach it. We'll also be able to detect unexpected interruptions and stop. So if you're working in an area that doesn't have a safety cage, it should be safe around other people. That's the goal. And we'd like to ship it with a camera so that we have lots of innovative ideas around that I can't get into just yet. We got to keep a few surprises for the Kickstarter.
Just to clarify, so you mentioned the latest one is closed loop, and you're talking about the
Cycloids?
encoders.
Yeah, okay.
But that's not quite the sort of closed loop I was referring to, so that would be closed loop with respect to the angles of all the joints on the arm, but you might still have some unaccounted for displacement at the tool head due to material.
Oh, I see. So you
things
use like
that.
a QR code to look at the tool head and detect linear error and then correct from that?
That would be one way to do it, sure. So then you'd have like some sort of absolute position on your tool head. But I was thinking actually something a little more global, so a depth camera that actually has in mind the workpiece as well, and actually does visual servoing, so you can account for actual movement of the workpiece and sort of any sort of external disturbances.
That sounds great. Thank you for volunteering. Welcome to the team.
If you don't mind me riff on that, I bet a Vive tracker would be perfect for that kind of application.
Something like that. Maybe higher resolution.
I've got a few
Yeah.
Vive trackers. I've done a lot of
Okay.
related work actually with visual servoing of arms and other things. And the Vive tracker, nominally, it has sub-millimeter precision, but there's a fair amount of jitter. And obviously, if you're doing you're swinging a sword in VR, then a momentary jitter isn't a big problem. But if you're doing visual servoing of a
Right.
physical arm, then a transient 10 millisecond jitter where the reported position varies by like half a meter could be disastrous. So you have to do some sort of filtering. So yeah, I think probably best for what we're talking about would be a time of flight depth camera like a Kinect 2 or the new Kinect Azure, ideally with some aftermarket optics, so you could actually zoom in on your workpiece and sort of get an arbitrary amount of precision.
There are many ways to skin a cat. That sounds good.
Yeah.
Let's implement it. As I said, thanks for volunteering. Do you have a question or you're just stretching?
Yeah, what's closed loop to open loop?
Right, so in an open loop system, like let's say one of the 3D printers, or classical 3D printers and CNC machines, when you first turn it on, you have to say go home, and the whole thing drives down to one corner and touches some switches. And I said, okay, I know where those switches are, so I know where the moving parts are, and now as long as I never miss a step, I can do my whole job. So you may have seen people talking about, oh, I was 3D printing a thing, I went to bed, and when I got up in the morning, it was supposed to be a column, and then everything's like this, because something had bumped it in the night. Maybe the cat tried to lean on it, and it didn't know, so it just kept going. And you get this wonderful generative art. Yeah. Yeah. The art of accidents. Yeah. Speaking of art, I'd like to hear from a few of the designers and the artist types that have been. No. But I hear you're interested in robotics. Tell me more. Where are you at? What?
So you said that if you could mainline all the knowledge in the world, you would do it. So as a person who's kind of like just starting to dip a toe into the world, what's thing one to go look at? As a person who's coming from a background of like creative coding and visual design.
Right.
Yeah.
That you can already code is a huge leg up. I also come from a coding background,
Yeah.
so I tried to do everything by simulating it first because I didn't know enough about mechanical engineering. My depth of knowledge in mechanics and engineering is growing quite a lot these days. I wish I knew more, but at the same time, I mean, there's so many hats to wear. If you're trying to make robots, certainly if you're trying to make them like I am, so that they're commercially viable, so that they make enough money that I can keep making robots, well then your main concern is, my main concern is Marginally Clever, the business, is a kind of robot. It eats pizza and beer and people's money, and it spits out robots that they want. That's its life cycle, right? And I'm trying to optimize that loop as much as I can. So from that I've just translated it into programmer speak, and then I'm trying to get the cycle time down, and hopefully no exceptions along the way. There are so many exceptions. Where would I start? I would tell new people just starting out that the goal you pick, if you don't have a goal, it's going to be really hard. You can't go somewhere if you don't know where you're going. You can wander around all day and experiment with, like, get obsessed with different microcontrollers, or just as you can get really obsessed with different types of paint, for instance, if that's your thing. But if you don't sit down and say, I'm going to actually make a picture of a house, then you might just be huffing fumes all day. I don't know.
I'll follow up with something slightly more specific then.
Sure.
In terms of the mechanical engineering of it, what's the thing that you had wished on the first shot about, like, making a thing move using a servo that you would know?
Yeah, so getting your own Arduino and doing this servo sweep, getting a single servo to move, is an excellent starting point for programmers and getting started with electronics. When I run classes in the past, like Introduction to Robotics, if you can have physical motion from your circuit, and you can have a sensor that feeds into your circuit, and then you and some kind of control logic in the middle, that's everything a robot is. We sense the world, we make decisions about it, we act on it. That's all living creatures. Yeah, that's it. Everything after that. I think there's a line somewhere that's like, the guy who teaches the whole of the Old Testament standing on one foot, and he says everything else is commentary after that. Everything else is decoration on top. You get those three things, and everything else is more like specific implementation. So I hope that helps.
Absolutely.
And if you're interested in learning Arduino and getting some practical hands-on time, I'd be happy to run a class at the Hackspace. Other qualified people, like there was Mimi, who was just here in the audience, is a member of the Hackspace, and she's great at that stuff too. So I'm not volunteering her to run a class. Talk to her about that. Okay. Anyone else?
Any other questions?
There's me.
Kind of interested in using robotics to assemble things wherein the robot is not really a fixed element with like one piece, but could possibly like assemble something at the scale of a room. And I'm sure that has like an entire universe of technical challenges. But,
It does.
But from the architecture and construction side, those sorts of problems I think are really kind of critical to solve. So I don't know if you can comment on that.
I recently, it's actually more than a year ago now, I saw a video of a Chinese company that put up a 30-story building in a month because they had planned everything down to the last detail. They were still using humans to do it, but since it was all Lego, in theory, it could be done by machines. They pre-made everything. Excuse me. They pre-made everything and then just bolted it together. You're absolutely right. There's a lot of technical challenges in there. Architecture with robotics.
I've seen some examples of drones like lifting up bricks and putting them down.
I've seen one in Australia that's, it's basically a boom arm, like the concrete one that comes, you know, when you see them at construction sites, it's a 40-foot up and then it's 40 feet down, and it's just the hose that spits concrete to wherever they need it. But these guys actually put a conveyor belt all the way through, and it was laying bricks. And all the way around until they built up the wall. They'd stop when the people had come in and insert the windows and the doors, and then keep going from there. And the last thing the humans did is put the steel A-frames on the roof, and you're done. So that was, and I bet they could also spit concrete along the way to glue those bricks in place. So that's already here.
Yeah, there's some companies that have like giant concrete 3D printers.
I've seen the pictures of the castle that somebody did in their backyard. That's just a scale model.
Yeah.
As I said, I'm interested in 3D printing on the moon. In situ resource utilization. We don't have to ship material up there. We use what's already there. So, yes, eventually I would like to do more with mobile robots when the time is right. I haven't spent more time thinking about it, so I can't give you a more in-depth answer. I love that now that we have this technology, we're not constrained to rigid square shapes anymore. That's going to create some really interesting things. I would like to see more integration of utilities. Like, a house is a living thing. It needs maintenance, but it doesn't, you know, we could have not just passive cooling, but where is the system in there that captures humidity out of the air so that you don't have to be connected to the local water supply? If each home were independent in that it captured solar energy and water and recycled its own needs, and then every person who lives in those homes is more able to help their neighbors, right? By being self-reliant. Hopefully they can give whatever surplus they have back, rather than everyone being dependent on a single point of failure, like the lake up in the mountain that could get poisoned from a tailing pond or something like that. Okay, so I hope that answers your question.
What's your earliest memory of robots or wanting to build robots?
Day one, still tired from the move. Day two, everybody talks to me like I'm an idiot. Stephen Wright. My earliest memory of wanting to make robots?
Yeah, of just being fascinated by something mechanical.
I had Lego as a child, and I had Meccano. I remember we used to have portables behind the school because there weren't enough room for us in the schools themselves. And in the summer, they felt like 5,000 degrees. So I went home and I used Meccano to make myself a fan. It had no safety cage. It spun as fast as it could go, and I was literally the coolest kid in school for like 2 weeks. Everyone wanted to sit next to me. Yeah. So I'm not going to say that was what inspired me to make robots, but when I was done at EA, I was burned out of making video games. Sounded great, and I thought there'd be money in it when I was like 13, because video games were new back then, and by the time I was like 30, it was, you worked in a room with 18 guys who probably don't bathe enough 40 dudes who don't bathe enough for like 18 months. And like an $80 video game is designed to last 8 hours of fun. It's like $10 an hour. If you pay $20 for a movie, you get 2 hours of fun. If you pay $80 for a video game, you get 8 hours of fun. This is the math they do. So they try to make a game that's fun for 8 hours, and if you don't last that long, well, you know, it averages out. So if you're making a video game, you spend 18 months, 10 hours a day, playing a very, very broken version of only this game. And if you aren't sick of it by then, I mean, you wonder why there isn't more like depth of plot and things, and you know, more things happening in there. It's because you burned out on your own game. And if you do succeed in getting it published, it probably comes out the same week as a AAA title, so no one has heard of your thing. And 3 years later, all the hardware has changed, and no one can play your thing anyways. So I needed something that was more tangible, and now I have I jokingly referred to it in one of my YouTube videos as my gallery of failure. It's a one room in my house that's just a collection of all of my robots over the years. What's left? Some of them, there's only like one burnt piece, or like this was the most interesting bit of this robot. The rest is, who cares? So yeah, the big inspiration when I hit a certain age, and maybe that was my midlife crisis, was that I wanted to build something more real and to actually hold it in my hands. How many websites can you build that are gone 6 months later or redesigned? You pour your heart into something like that and get the kerning just right, and then they're like, no. So I feel I have a lot more agency now, and people really like what I'm doing. Also, as a bonus, robotics is a very small industry now, growing, but very small. So it's not hard to climb up the ranks and get known. You know, if you're one of the early pioneers, people will remember that. And as I said, there's lots of money on the table. You just got to pick it up. So y'all want to come help me out? I've already got a good head start. Join me together. Yes. Occasionally, I let my inner supervillain out. Yeah.
I know what
Well-
you meant by saying, you know, owning the robot is to own all the resources.
Yeah. I used to say if the robots take all the jobs, only the robot makers go last. It's also job security. The robot makers will automate their own job last. So, yeah. I would not get into being a dental hygienist in like the next 5 years. They're very highly paid doing a repetitive task, under the guise of dealing with strain injury, they will start working on machines that can clean your teeth better than they could. And a neural network will learn how to do it better than they could. It's $80,000 per hygienist, 200,000 hygienists in the United States alone. And the dentists have more than enough money to want to experiment with those machines.
Is anybody gonna trust a black box neural net controlling an arm inside their mouth?
Oh, God. I would.
He gave me the right stuff.
Does anyone trust a Tesla car to drive itself? Yeah,
To be honest, there's
You're
lots of
trusting it
edge
with your life.
cases where you would expect failure.
yeah.
And so if there's a robot in my mouth with access to my teeth and my tongue,
Mhm.
I probably prefer that it's not running a neural net, because the whole operation needs to be comprehensible by humans that can verify. That's just my opinion.
I appreciate that. We do it the same way the Tesla cars do. We train people up. The hygienist sits in a more comfortable position and operates, and we get thousands and thousands and thousands of hours of labeled data. This is the correct way to do the job, and we feed that through the network. And eventually we've got 6 nines, and we're done.
This fellow wants to ask a question.
Yes, sir.
You were saying that robot makers would be the last to automate their own jobs. What if a robot maker trains an AI to design their robots?
Well, then all jobs are gone. That's the last job. Yeah.
We got a question online here.
Yeah.
How much do you charge for designing and building a custom robot? And can you tell us a recent example of one?
The last thing I custom designed for someone was a hat covered in LEDs for 5 Alarm Funk.
Mm-hmm.
I very, very rarely do that anymore. Firstly, because designing something from scratch is an enormous R&D cost. It's like, well, you tell me what your budget is, and I'll tell you how long it'll last, and we'll put that many hours into it, and we'll give you progress reports along the way. Actually, there was another project. We were paid a fair sum of money. No, we were promised a fair sum of money and never paid to build a machine that would sort Yu-Gi-Oh cards. They were buying pallets full of collectible trading cards and manually sitting there and sorting the goods from the bads and the valuables from the less valuables. And they wanted a machine that would look at the card, identify the card, and sort it into a bin. And we actually built it. It could sort and it could identify. And we were pretty good. It needed more iterations to get it to the speed they wanted. And we told them where we were at, and that we'd spend the hours, and we'd like to get paid, please, so we could keep going. And we never heard from them again. So it's still sitting on my desk in my gallery. Great question online. Yes.
Do you ever play with like generative outputs, like anything where you don't really know what the result is going to be when you run it?
Some of the Michelangelo art styles, there's one that's Voronoi stippling. It throws a bunch of dots on top of the image, and then if you treat the dark parts of an image, like the valley, and the light parts at the top, the dots kind of roll down towards each other, but they also push away from each other. They can't get too close, and you're not sure what results you're going to get. I would mention a website called turtletoy.net. People have been putting generative art on there, and it's all line art. So it was really, it even has an export button. All we had to do is make sure we support that. And a lot of the stuff on there, you hit reload, you get something totally new every time. So we can draw that. I can't think of the last time I did something that was generative for my own like aesthetic needs. Yes?
Following up on that, do you have the vision to make it real-time generative using your robot?
Like this would look out into the world and use random data to draw something on here?
Yeah, or however,
Or just like feed it G-code?
yeah.
Yeah, you can feed this G-code all day. So if your laptop is, the Michelangelo software is running on there, and you've written a script into it that can take a rand value and do something cool with it, why not?
Just sort of following up on that idea, it just occurred to me, not a random drawing, but it would be neat to set up pretty much exactly what you have there at a place where there's a lot of pedestrian traffic with a digital camera, have someone take a seat, take a picture, run it through an automated filter that does edge finding outlines, and then draw them automatically, and then sell the picture for $5. I did have a technical question though about the device, which is, I can't quite tell, but I suspect just from intuiting how it works, as well as visually observing it, it seems to be a bit on an angle. Am I correct? And that would be because you can't apply pressure.
Up to vertical.
Right.
I've put this on a whiteboard in my office and drawn with the whiteboard marker. Beyond that, you have a problem because it's hanging out in the midair. But yes, we've tested it with perfectly straight. The easel is portable. I can fit it in my car. So.
Would you consider it, sorry, I don't mean to talk all the time, but it's a follow-up question. Would you consider it more useful if there was a means of applying pressure?
Perhaps.
I guess what I'm saying
I'm curious
is
to see how you would implement it.
well, for instance, like
I have
if you had
mechanical limitations with my choices in
Right.
here, hardware choices. We can have a very long and pleasant conversation about that.
Mhm.
Yeah, there's lots of trade-offs and things that very subtle. UBC Capstone is a project where students and industry come together to try and work on projects. And every year I've submitted like 6 projects. And one of the few times students came out and all they wanted them to do was to redesign this section to be better based on a couple of criteria. And they told me that they thought it was too simple and they weren't going to spend 3 months on it. If it's so simple, show me. Do it in a weekend and blow my socks off. But yeah, I couldn't goad them into it. So, yeah.
Oh, so you have a drawing robot here. Have you tried to use your mechanical arms to make sculptures?
I would love to do that. One of my goals, we have a long list of use cases we want to demonstrate that the arm is good for. And a simple case would be a Dremel on the end of the arm and a block of foam, and it would carve that into a sculpture. We might add a 7th axis so the block of foam rotates, and then it's a lot like a lathe. A CNC lathe that spins something very fast. We would do it slowly and carve all the angles. We could get shapes that you might not be able to do with a 3D printer. I say might. There's a lot of things a 3D printer can do that other methods cannot do.
Right.
I would also really like to go revisit that drink mixing robot, only do it with the arm. I know if you've been watching online in robotics, you've seen like a KUKA industrial arm that can pour a beer. And I know that, I think it's Princess Cruise Lines now has a couple of arms that do bartending.
Okay.
And they work together to make a thing. And That's really cool. Why shouldn't everyone be able to have that? I would love to take the first 62 that can do it and go to Science World after dark and then auction the arm off to the highest bidder. Be the first in Vancouver to own your own bartending robot. You can even put a speaker in it and it'll ask how your day is going.
Apparently in Japan, I think in Hokkaido, there's like a hotel, and the concierges are actually robotic dinosaurs.
Nice.
That welcome you and give you a room key.
And there's another one in Japan where the robots are actually teleoperated by people who are quadriplegic or who have other disabilities. So they get jobs, and this is a big inspiration for me. I would like that a business owner buys one of my arms, puts it on a table, puts a card in front of the arm where the camera can see it, and on the card it says what they want it to do. And 15 minutes later, it starts to move on its own because someone from home who couldn't have, there was no access ramp, but whatever, they can work from home, they can look through the camera, they can drive it from there, and they can make it do the thing. And so they've already got the expertise, and we put these people together as a service. And yeah, so the arm is open source and anyone can build it. We'll sell them fully assembled, or like Prusa. We want to be the Prusa of robot arms, basically. And then as a service that we can upsell, you know, there's so many avenues for revenue here, and nobody's serving anyone. The next closest arm that can do what ours is $10,000 US. We think we can do it at a handsome profit for a quarter of that. And that's the fully assembled kit. But we have another 50-some days before the cutoff for the New York Maker Faire, and we're really trying to get our machine running before then. If we can do it, then we're going to say yes, we're going to that fair. And from that moment on until September the 28th, we will be doing nothing but marketing and promotion and showing use cases so that we can, I'm hoping that we can sell the arms before the fair, and then rather than doing business at the fair, we're just making final delivery of product. That would be, I would love to see people walk in. We have a big pile of boxes, and as the week goes by, they just go, yeah. Yes?
What would you say are the biggest challenges of scaling a production like that?
Oh, wow. Well, hopefully we can use the arms to help scale that production.
Yeah, I suppose.
The biggest problem is the seed money. I mean, if you've already, people are already saying, take my money, I want the robot. I'm not going to take the money until I know the robot works. But the instant it works, I'm happy to take all your money and immediately start hiring, call all those people who come in and help me build Michelangelos in the past. Get in here, boys. Get in here, girls. We got to make this happen. If you don't call yourself a boy or a girl, cool. Just get in here. Yeah, let's do this. Yeah. Where are my dogs at? I don't know. Yeah. So,
Okay.
A business runs on money. That people won't work for free.
Yeah.
Certainly not in Vancouver. So if your money's good, then all you need is more money and you can go faster.
All right. Well, thanks so much.
Thank you.
All right.
Great questions, everybody, and thank you for coming out.